Welcome to part 3 of our drilled shaft video series. If you haven't already, we recommend watching parts 1 and 2, which we've linked in the description below. In this video, we're going to focus on the tools and equipment related to drilled shafts, including the types of drilling systems, mounts, tools, and more. Before we begin, we'd like to thank our sponsor who helped make this video possible. Peer Research, your solution for deep foundation drilled shaft rebar and rebar cage alignment for over 30 years. Now let's get back to the video. Depending on your project needs, your drilling and excavating work will require a variety of tools and equipment to get the job done. While choosing these tools and equipment, everything from the location of the project to the type of soil and substrate to the moisture content in the ground will have to be considered. Keep in mind that before the contract even reaches the billing stage, the client should have already conducted all necessary inspections, core sampling, and other testing phases. All of this data should be available to you and your team as early as possible in the process. This information is crucial to determine the correct tools and equipment for the job. Once you know the ins and outs of the location and the ground base, then you can decide how you'll proceed with the excavation. Let's get an overview of drilling systems and go over the most efficient systems used for drilled shafts. Rotary drilling. Rotary drilling is used to form a deep observation borehole as well as obtaining representative samples of rock. Depending on where the job takes you and what kind of material you have to drill through, there's various rotary drilling options, including augers, drilling buckets, and core barrels, to name a few. When considering rotary options, the most important factors that set each apart are the torque and the amount of capable downward force. While there are other factors such as substrate material and power, torque and downward force are the factors that will have the most impact on the job. Mechanical and hydraulic systems. Mechanical systems have been popular for many years, particularly because they're simpler to operate and repair while still supplying enough power to the rotary system, meaning there's a fixed mechanical system attached to the drive shaft, and that's what's providing the power. However, hydraulic systems are quickly gaining ground as a popular choice as well, mostly due to their ability to supply comparable power while offering more flexibility in the height of the tool. With the ability to move up and down the drive shaft, the rotary tool isn't limited to the distance between the mechanical drive and the rotary table. Oscillator and rotator systems. One of the more expensive hydraulic systems is the oscillator-rotator system. This setup utilizes a solid pipe casting that rotates around the drilling bucket while the excavating is in progress. This way, a downward pressure is exerted as the rotary table works away. Another rotary drilling setup involves putting the rotary drill on top of the casing. These casing-mounted drive systems rely on a process called reverse circulation drilling, in which the multifaceted rotary heads work away at the soil while an airlift moves the debris. Due to the fact that tremendous torque is being applied in two directions at the same time, these types of setups require strict attention to the design of the drilling as well as the layout of the location. Manual excavation and drilling. Believe it or not, even with the efficient drilling systems available today, manual excavation techniques are still being used by many contractors today. For some types of jobs, like reinforcing or repairing the underpinnings of existing structures, manual excavation may be more cost-effective as well as more efficient. And in some cases, there may be a geological reason why manual excavation is required, like drilling through or removing a massive rock. However, it's important to note that anytime workers are put below surface level for this kind of work, there are major safety considerations that must be put in place. Depending on the size of the drilling, you may have to reinforce the area to avoid potential collapse, redirect any groundwater below the workers, or even ventilate the area with fresh air. On a final note about drilling systems, for some projects, a combination technique may be required, utilizing both manual excavation and mechanical and hydraulic drilling. For example, there may be workers beneath the soil surface who are guiding a clam or hydromill. Mounting the drilling system. The most versatile machines are generally fixed to a movable source, which could be anything from a truck to a crane. This would allow you to maneuver around the job site and even from location to location. Some drilling machines are still mounted to a fixed casing though, which would affect the versatility of your machine. Here's a few points to consider with mounting. Truck mounted. With this type of setup, your drilling machine will have the greatest amount of mobility, but convenience comes at a price. Although hydraulic systems in truck-mounted rigs aren't unheard of, most truck-mounted drilling machines must rely on a mechanical system instead. Also, truck-mounted machines may have difficulty reaching certain heights, and the entire rig will have to overcome specific limitations depending on terrain, reach, rebar caging, and more. Crane-mounted. Of course, larger and more difficult projects may require different types of mounting. In these cases, crane-mounted machines usually afford you a wider range of options. For example, if you're drilling in the pilings for a bridge project, a crane-mounted system is ideal for reaching out over the waterway. However, you sacrifice mobility when moving from a truck-mounted to a crane-mounted system. Just getting the drill in position can be time-consuming and costly, and can even require skilled movers to transport it. Crawler mounts. A good in-between option for truck-mounted and crane-mounted options is the crawler-mounted rig. While it's still a bit more cumbersome than a truck-mounted machine when it comes to getting to the job site, crawler-mounted rigs will allow you to move around the job site with relative ease, which is difficult for a crane mount to accomplish. Due to their versatility when it comes to tasks like working on slopes or uneven terrain, crawler-mounted rigs are becoming more and more common, especially lightweight models. Excavator mounts. Perhaps one of the best of both worlds options is a crawler-mounted rotary rig that attaches to an excavator. With the maneuverability and mobility that this excavator offers, this system is usually a hydraulic rig that's attached to the arm of the excavator. That gives you more flexibility for the types of drilling that the job requires. This kind of mount is ideal for low headroom jobs, such as near and under overhead power lines or bridges. Well, do you like what you see so far? We'd really appreciate it if you'd like the video and subscribe and turn on that notification bell. That way you'll know whenever we drop a new video. Now, let's get back to the video. Drilling tools. Now that we've discussed the different types of drilling systems and mounts, let's look at the various types of drilling tools available. Rotary tools. As some of the most common drilling tools used today, rotary tools offer multifaceted surfaces that turn in order to bore into rock, soil, or other substrates. Here's some of the most commonly used rotary tools. Augers. Augers consist of some sort of spiralized cutting edge or a blade that turns in order to work its way down into the drilling material, and they can be specialized for drilling into soil, slurry, rock, and other material. One of the most important factors in an auger's design and how it's chosen for a specific job is its flight, or the blade-like feature that lifts the drilled material up out of the way. Depending on the project requirements, these flights may be closer together or farther apart. They may be higher or lower in number, or may even have a slightly upward scoop shape to aid in removal of the drilled material. Whatever the case, the goal is to ensure there's no unnecessary resistance from the substrate, which would put extra strain on the auger as well as the drill. Drilling buckets. Generally used for excavating loose soil instead of rock, a drilling bucket consists of a large container at the end of the rotary drill. The container has two openings opposite each other which collect sand or soil as the bucket turns, then flaps inside the container to stop the material from falling back out. When each load is filled, the bucket is removed from the hole and the material is dumped out via a door on the bottom of the bucket. Core barrels. Because drilling buckets are typically used for loose soil and some augers are only designed for certain types of rock, these limitations make the core barrel a viable option for some drilling projects. These tube-shaped devices can be single-walled, double-walled, or even specially made for rock drilling. Core barrels function by producing a drilled core that's held in place by the friction of more material entering the tube, and it's lifted out of the hole with a fairly even rate of resistance. At this point, the material is brought out and deposited on the surface. Belling buckets. Generally used for widening the base in stable soil, a belling bucket moves underground with its cutting arm close to its sides. Then the downward force causes the arms to extend out and cut the soil as it continues to operate. One of the drawbacks to this method of drilling is that the bucket often requires extensive cleaning afterward. Percussion tools. As the name implies, percussion drilling tools rely on impact force rather than rotation. These percussion tools are especially effective for rocky ground as material is broken up rather than cored. Clamshell and grab buckets. Of course, clamshell buckets aren't just for moving the leftovers once the drilling's taken place. On sites where rotary tools aren't going to be effective, clamshells can often do the actual excavation too. Depending on the size and looseness of the soil, these buckets may be all that's required, though they're often used in conjunction with some other method. Hammer grabs. Hammer grabs are often considered the best of both worlds. With the jaws at the bottom of the hammer closed, it's dropped into the hole and used as an impact tool to break up or loosen rock and soil. Then, either after being lifted or while still down in the hole, the jaws are opened and the loosened material is grabbed and lifted out. Although they tend to be heavier and more expensive than other drilling tools, hammer grabs save time, considering that one machine can accomplish multiple goals at once. Rock breakers, drop chisels, impact hammers. For projects that require the underground material to be simply smashed, these specialty tools rely on their weight, gravity, and usually a long chisel point to break up heavy layers of rock. At this point, a clamshell can lift out loose pieces, or a hammer grab can finish breaking up the rocks before removing them. Blasting. Blasting is not the most common method of excavation, and the reasons should be obvious. In addition to safety concerns, there's the potential for weakening surrounding soil and structures. Blasting is also an expensive process due to the necessary expertise and permits. Post-drill. Once the drilling has taken place, excavation continues with the removal of the material. While clamshells and grabbers are common methods, they're not always going to be ideal. Other methods have been created, like airlifts and hydraulic pumps, which actively force loosened material out of the shaft. The method you choose will depend again on the material you've excavated and the design of the project itself. When airlifts or hydraulic pumps aren't ideal for the project, another option is grouting. Grouting is generally used if the substrate isn't very stable or if the hole was particularly large. Soil mixing is another option. With soil mixing, the shafts are stabilized by columns of mixed soil cemented between them. One of the most innovative ways of securing a shaft is to form a cement liner. If stability is expected to be a problem, a wider than necessary shaft is excavated and then filled in with concrete. Once the concrete is cured and hardened, then a new shaft is drilled into the concrete to the correct width. The end result is similar to a vertical tunnel of concrete that's supported by the soil around it. Again, we'd like to thank our sponsor, Peer Research. Call 800-342-2409 or check out peerresearch.com to view their entire lineup of products, including the Quick Lock Pier Boot Spacer, which is designed to support a reinforcing steel cage within a drilled shaft with a concrete cover requirement. They're also great for supporting reinforcing steel over waterproofing in mat foundations and providing vertical support of slurry walls. Well, that's all we have for now, and be sure and subscribe so you'll be notified whenever we release a new video guide.